Hey guys, this is Professor Janacek, and I want to go over some examples where we find derivatives using the product rule and the quotient rule. Let's take a look here at example 1. We're going to take the derivative of x squared e to the x. So, in this case, x squared is my first function and e to the x is my second. And there are several ways of remembering the product rule. I like to remember that it's the derivative of the first times the second plus the first times the derivative of the second. So let's write that down. It's the derivative of the first, which is x squared, times the second, which is e to the x, plus the first, x squared, times the derivative of the second. All right, well, let's go ahead and see what we get. The derivative of x squared, we can use the power rule. That's just 2x. And then we have e to the x still there in the back. Plus the second term, I have x squared already there. And now all we have to do is take the derivative of e to the x. Oh, that's an easy one. The derivative of e to the x is simply e to the x. And there you go. Nothing can be simplified here. We can't combine anything, so that is it. It is true that you could factor out the e to the x if you wanted, and that is a common practice. Of course, you could also factor out e to the x and then write the polynomial in descending order. So those are all acceptable versions of the answer. All right, example 2, we've got d dv of v squared times 2 square root of v plus 1. First thing I'm going to do is to go ahead and rewrite that square root of v as v to the 1/2 power. I think that's going to make life a little bit easier. Now, I could, if I wanted to, distribute this and then just use the power rule, but I'm going to go ahead and treat this as a product and use the product rule. So my first function is v squared, and the second function is 2v to the 1/2 plus 1. So again, we're going to follow that rule of taking the derivative of the first times the second plus the first times the derivative of the second. So we end up with, let's see, the derivative of v squared gives us 2v times 2v to the 1/2 plus 1 plus we have v squared times the derivative of 2v to the 1/2 plus 1. So the derivative of 2v to the 1/2, that's the power rule. 2 times 1/2 is 1. Subtract 1 from that exponent. Take your time with that if you need. We end up with v to the negative 1/2 power. And then if we take the derivative of the 1, that just gives us 0. And so we don't need to write that at the end. All right, let's see what else. We can go ahead and clean this up just a wee bit. Let's distribute there in the first, distribute here to begin with. That gives us 4v to the 3/2 plus 2v. And then in the last one, if we multiply these, we end up with v to the 3/2. Just combine those exponents. Now I see that I can combine a few terms. I can combine the first term and that last term. So we end up with v to the 3/2 plus 2v. And there we go. Not so bad. Okay, on the next one, we've got d dx of x squared plus 3x plus 4 over x squared minus 1. Now this is absolutely a quotient. In this case, I often consider the numerator my first function and the denominator as my second function. So looking back at the multiplication rule, it was basically that we took the derivative of the first times the second plus the first times the derivative of the second. Now I'm going to follow that same little pattern here. Be careful, that is a prime mark there. I'm going to follow that same pattern in the numerator, so it's going to be the first times the derivative of the second, but now minus, oh wait, I wrote that completely wrong, even saying it wrong. It's the derivative of the first times the second minus now the first times the derivative of the second. Now notice that follows the same pattern as our product rule. Couple of differences. One, we have subtraction here, and then we also have to divide by the second, or the denominator, squared. So again, I treat my numerator as the first function and the denominator as the second function. So what does that give us? Well, here we have the derivative of the first, or the numerator, times the second minus the first times the derivative of the second. And all of this is being divided by the second one, or the denominator, squared. All right, well, let's go ahead and evaluate these derivatives. So the derivative of x squared plus 3x plus 4 gives us 2x plus 3, and then times x squared minus 1, minus, we have x squared plus 3x plus 4 next, and then we're going to take the derivative of x squared minus 1, which is simply 2x. Now here in the denominator, I'm going to go ahead and leave this x squared minus 1 squared. The reason I'm going to do that is because it's factored in this form, and if I need to reduce it later, I'd rather it be factored than not factored. All right, well, we can go ahead and multiply some stuff together. We will multiply those two binomials, multiply this stuff, gives us 2x cubed plus 3x squared minus 2x minus 3. Watch those positives and negatives. All right, in the second bit, we'll multiply all this. I'm going to go ahead and multiply by 2x, but I'm also going to multiply by that negative. So watch those positives and negatives here as well. So that gives us negative 2x squared. Wait, that's a cubed. Minus 6x squared minus 8x, and of course this is all over x squared minus 1 quantity squared. And it looks like we can combine some things. The 2x cubed and the negative 2x cubed combined to give us 0. 3x squared and negative 6x squared combined to give us negative 3x squared. Negative 2x and negative 8x will combine to give us negative 10x. Oops. And then the negative 3 is the only constant. And my denominator still as is. Now that numerator doesn't factor, so I won't be able to reduce that, so that is as far as we can go on that one. All right, well, not so bad. Moving on to example 4, we're going to take the derivative of e to the negative x. Now, this could be worked a few different ways, but in the world of product rule and quotient rule, I want to make sure you are comfortable working with these rules. So let's go ahead and write this as a quotient. Notice this is e to the x. Yes, there are other ways of taking the derivative of e to the negative x. The chain rule is very popular, but I can also work it using the quotient rule. So using the quotient rule, we'll take the derivative of our first, which is just 1, that's the numerator, times the second, in this case that's our denominator, e to the x, minus the first, which is our numerator, 1, times the derivative of the second, which is, in this case, the denominator. All of this will be over the denominator squared. All right, well, let's take a look at these. Let's see, the derivative of 1 is just 0, and then times e to the x, minus 1 times the derivative of e to the x there in the back is simply e to the x over e to the x squared. All right, well, of course, 0 times e to the x, that term goes away, and so we have negative e to the x over e to the x quantity squared. You'll notice I didn't rewrite that exponent as 2x because I see here that it can now reduce. I'll reduce an e to the x, that gives us negative 1 over e to the x, which, by the way, is negative e to the negative x. So the derivative of e to the negative x is negative e to the negative x. All right, on to example 5. We're going to take the derivative d dx of x squared plus 1 over x squared minus 4. Again, following the quotient rule, we will start with the derivative of the first, x squared plus 1, times the second, which is the denominator, x squared minus 4, minus the first, which is the numerator, x squared plus 1, times the derivative of our second function, which is the denominator, x squared minus 4. All of this is over the denominator squared. Okay, well, let's see. If we take the derivative of x squared plus 1, we end up with 2x. That's being multiplied by x squared minus 4 minus x squared plus 1 times the derivative of x squared minus 4, which is also 2x. Keep the denominator as is in case I get to reduce it here in a bit. Let's see, in the numerator, we can combine, we can go ahead and multiply those. Here in the first one, I simply distribute that 2x. That gives us, and I'm not sure why that has something that looks like a negative on it. There we go. We get 2x cubed minus 8x. In the second one, I'm going to distribute the 2x along with that negative. I can distribute both of those. So that gives us negative 2x cubed minus 2x. And then the denominator is still x squared minus 4 quantity squared. Now it looks like we can combine some things. In the numerator, 2x cubed minus 2x cubed, that gives us 0. Negative 8x minus 2x is negative 10x. And the denominator is still x squared minus 4 quantity squared. And it looks like that's about all we can do. No reducing here. That is it for that one. And there we have come to the bottom of another page. Enjoy!